There we go. All right, so our goal here, you guys, with trig at this point is it's all about replacement. And it's kind of like solving a puzzle. You got to find the parts that match and and we're going to do a lot of substitution. We're going to do a lot of trying to expand the function and simplify it and cancel it. Okay. And I kind of always think it's like putting a puzzle together. Okay. Miss Handy did some answer keys. So I've added some new examples in here this year. And it sounds like I may have an answer key typo on 14 there. So it might not work out. We're going to see. So we're looking at example. We're going to start with example 9. In theory, it's telling us that these are the 5 answer choices that we're allowed to get. Okay. And we might get some of them more than one time, and that's okay. All right. So we're going to look at this, and these ones, you guys, it's more like sometimes I'm going to have you, there's so many different ones that you can do. I'm going to do a couple sometimes and have you do one. And sometimes I only have one example in there, like the rest of or in the notes that's like it. So we're just going to do it together. Okay. And then you'll see it probably again on the homework. Unfortunately, there's only so many ways we can put these together, and just it's kind of the nature of the beast. Okay. All right. So our goal is to try to replace one of these with something. So I've got cosecant and sine, and I'm supposed to try to simplify that expression and get either -1 sine x, cosecant x, or cosecant squared. Okay, that's the goal. All right. Looking at, yes, you need other ones? You have the front part? No. That might not even be all. There might be more.
I think the 158 page.
Okay, hold on. Edgar, I don't think that's all of it. It was a huge mess this morning. I tried to clean. Those are the stacks. I will throw them back here. Oh, here we go. Anybody else missing yesterday's page? Okay. All right. So let's look at, so the first thing I try to do is I try to look for ways to put things in sine and cosine in terms of that. Okay. So I'm looking at cosecant x. All right. And I know that it can be, what is cosecant x's reciprocal? And notice I have the sign. I'll put these signs back up. I normally have them. Look, that's a picture of that window right there. I normally have them all up in that window. So what is the reciprocal of cosecant? What do we see? 1 over sine. So I'm going to take cosecant out, and I'm going to put in 1 over sine x. And then I'm keeping the sine x exactly the way it was. Okay. What happens? The signs cancel, right? And what's my final answer? 1. Is that one of the things that was on my list? Yeah. Pretty simple. And it seems like something that we would just know. I need you to show me this step. Okay. One thing we can do with identities is we can do this thing called verification. We're not going to, just because of time. And it's not something that's necessary for the next class. But you have to, the steps are really important that you're showing the work. Okay. All right. Let's look at example 10. So there's 2 things I can do with cotangent. Okay. And usually when I put this sign up there, typically we want to put things in terms of sine and cosine, okay? If I were to use cotangent is 1 over tangent, it wouldn't get us anywhere. So typically on the reciprocal identities, I don't use tangent and cotangent as reciprocals. I typically use them, as the quotient identities. I zoomed in and now it's all disappeared. So I'm going to use this one here for cotangent, okay? Because it has the cosine and the sine in it, right? So I am going to replace cotangent with cosine x over sine x, right? That's what I'm doing for this one. What's a better name for secant? Not cotangent. What's secant? 1 over cosine. So if I don't have like 2 numbers to flip, which is what we've been doing, it's 1 over whatever the reciprocal is. Okay. All right. So we're going to replace this one with 1 over cosine x. All right. Why was that good? What happens now? Yeah, the cosines cancel out. And look at across my numerator, I've got 1. Across my denominator, I've got sine x. Okay? All right. Another rule of thumb with trig is we don't leave anything in the denominator. Okay? So no denominators if you can help it. Okay? We try to get rid of them. So another way to write 1 over sine x, go back and look at our functions. What's 1 over sine x equal to? Cosecant x. So we would replace that with cosecant. All it is, you guys, is we manipulated that function and did a lot of substitution. Okay? And just learning that pattern. Okay? All right. I want you to take we're going to pause and have you try one on your own before I change up the type it is. Okay? So example 11 is very similar to example 10. Okay? So I want everybody trying example 11 on your own right now. Okay? So everybody do 11. You turn tangent into sines and cosines. Yep. Okay. Yeah. Okay. Let's take a look at it together. Okay. So it wasn't exactly what I showed you on the last two. Okay. But it was close. It had a lot of the same elements. What's another name for tangent? Sine over, and we've been working with that for a long time, right? Sine over cosine. So I replaced tangent. Is there anything I can do with cosine? Just write it down, right? Okay. What happens? What cancels? The cosine cancels. Okay. And then I know that it is just equal to sine x. Is that one of the things that was on my list up here? Yeah, it was. Okay, so it was one of the things I was supposed to get. Okay. All right. Let's take a look at the next one here. Okay. So the next one, anytime I see squared things, okay, I think the pink Pythagorean identities. I call them the pink Pythagoreans because that's the color of the sign, right? So I'm going to try to replace something with a Pythagorean identity and see what happens. Okay. So I'm going to come over here to my Pythagorean identity sign. I'm going to blow this up a little bit. And let me explain my sign. I know I wasn't here on the first day we did this because, I had a child at home throwing up. So, I would have much rather been here. Trust me. Okay. Always when I'm at home with sick children, I would much rather be here. So you'll notice that really the identities are these first three. Okay, so those are the originals. All I did with the rest of the sign is move the function around to help you see it better. So like on this first one, to get this first one, I took and I subtracted sine to the other side. Do you see that? So it's the same equation manipulated a different way. Okay. On this in this one here, I took and I moved the cosine over. I subtracted it to get here. Okay. So, and it's the same for the last two equations. I just manipulated the function differently. Okay. So how I use this then is it told me, let's see, I had a choice. I get to either go find tangent squared or secant squared. I'm going to find secant squared and see what that's equal to. Okay. So I'm going back to my sign and I'm looking for secant squared. Do you see how this is secant squared? So I'm going to replace secant squared with 1 plus tangent squared. Okay, so we're putting that in. So I know I've got a minus sign. I'm going to go 1 plus tangent squared x. And then I'm keeping the tangent squared part that was up front originally. You don't have to replace both. Just try replacing one. Okay. All right. Now, look at the algebra that's there. So we're going to basically do trig with all the algebra rules we've had so far. Okay. What does instinct kick in and tell us to do? Distribute. See, you already know this. Okay. So we've got the tangent of a tangent squared x minus 1 minus tangent squared x. So we distribute it. Okay, now it's combining like terms. Instead of x squareds, it says tangent squared x. Not a big deal. You can handle that. Okay, what happens? Yeah, aren't these the same thing? Opposite signs? What do we do with same thing, opposite signs? Cancel out. What's my answer? -1. Is that one of our choices? Yeah. Okay. Any questions on example 12 there? Okay, let's take a look at example 13. Okay, so let's look at 13. Okay. We have, so the first thing I want to do is I want to go look at my sign and see if I can find something that is exactly the same, maybe as this. Let's see if that's on the sign. So you can either look up at the one up tip here, okay, or I'm going to put it up here. So I'm looking for cosecant squared minus 1. Let me zoom out and kind of get back to my pink sign here. Where did it go? It disappeared on me. There it is. Yeah. Okay. So we were looking for, and it all zoomed funny. Come on. Come back. Oh, goodness. Now it's zoomed funny again. All right, there it is. Okay. All right, so we're looking for 1 minus cosecant squared. Okay, so let's look for that. See if you can find it on there. Okay, 1 minus cosecant squared. All right, so I'm looking. Ooh, 1 minus cosecant squared. I don't see 1 minus. Let's see, it's supposed to be. Oh, no, sorry, it's cosecant squared minus 1. Cosecant squared minus 1 is right there. So what am I allowed to replace it with? Cotangent. Okay, so we're going to put that in. Okay, so I'm putting in cotangent, okay, squared. And if there's a squared, we're going to keep the squared, right? So cotangent squared x over cotangent squared x, because we replace this, right, with this. What's that reduce to? That reduces to 1. Okay, so the hardest part is making sure you're finding the right formula on the chart. And again, I'm not making you memorize those. You're going to have access to them. That sign will be up. I also have a page that you can look at them on as well. Okay. All right. We think Mrs. Hamby, and I think I have a typo in this one, and I tend to agree. I'm going to make this. It looks like it needs to be. I'm going to double check. Let me check my sign really quick because that did not zoom well. I think I have a sign mistake. Okay, let's do this. Okay, so on number 14, I wrote it wrong. Okay, so what I want you to change it to is, let's take this off of there. Okay, ooh, that did not white out the way I wanted it to. So let's take that off of there and make it -1 at the back. Okay, so secant squared x -1. All right, should be very similar to example 13. I want you to see if you can find that on the sign, okay, and see if you can simplify that function. So everybody take a minute and try it. Okay. Okay, let's take a look at it. Okay, so what we're looking at the sign, the pink Pythagoreans, right? Because we found squared stuff and we found things that look like them. Where did my sign go? It keeps disappearing on me. I went way too far up. Okay. All right, so I want secant squared x -1. Did we find it on there? Oh, good. It's tangent squared. It is just being a real big pain today and disappearing on me all the time. Come on. How did I get back to example 2? All right. Okay, so I'm going to try to get to it again here. All right, so, oh my God. It's being ridiculous. All right, so we're going to use that sign up there. Everybody look up at that pink sign because it's not going well for me on digitally, so I can't write on it. All right, so in that pink sign right there, we're looking for the secant squared x minus 1. So do you see the second row? Okay, I want you to go all the way to that last column in the second row. Do you see how it equals tangent? Okay, so that's what I am replacing this one with. Okay, so this guy here gets replaced with tangent squared x. The denominator stays the way it is. Okay, all right, so what's tangent squared over tangent squared? 1. Okay, so we're going to use that sign up there if we can. Okay, because I think the reciprocals you hopefully know. Any questions so far on that piece? Okay, so sometimes they're nice and they give us the answers. That's what happened in these ones. Okay, sometimes they're not so nice. Okay, so in this one, in these examples, they say use the fundamental identities to simplify the expression. So we just have to get it as simple as we can. Okay, and we don't have an answer to go by. Okay, the first thing I'm noticing is I am noticing a lot of, I'm noticing some Pythagorean here. First of all, this looks awfully Pythagorean to me. Okay, so I want you to look at the pink sign. Okay, look up at the pink sign and see if we have 1 minus sine squared somewhere. Just look for it. 1 minus sine squared. All right, did we find it? What's 1 minus sine squared equal to? Good job, cosine squared. And I have another version I can put on the other side of the room, so I know some of us are in weird places. Okay, so this replaced that. Do I have another name for secant? 1 over cosine. Okay, because I'd rather, if I can cancel things, I like to cross things out. It's kind of like when we did rational expressions. Crossing things out is fun, right? So I know that secant is 1 over cosine. Now, since that was a secant squared, we're going to use a cosine squared. What happened that's really good right now? What do I get to do? I get to cancel. What's my answer? 1. It won't always be a 1. It might not always be that pretty. Okay, this happens to be nice like that. Okay. Any questions on what I did? Again, we're using our identities. We're replacing. We're trying to make it as simple of a function as we can. Okay. All right. Let's look at the next one here. Okay. We're supposed to use the fundamental identities to simplify. Okay. All right. I don't know if I put this. Okay. So if all else fails, put things in terms of sine and cosine. Okay. And I am also allowed to like separate out fractions and stuff if I need to. Okay. So let's see what we can do with this. And it might take me a couple of steps. All right. What is another name for cotangent? Okay, we can go cosine theta over sine theta. Perfect. Okay. All right, what's another name for tangent? Sine theta over cosine theta. And again, for tangent and cotangent, that's the safe move. Okay. All right, I'm going to just leave cosecant theta down there for now. What do you notice happens with the numerator? Oh, so we get cosines cancel, sines cancel, so my numerator becomes 1, and then my denominator is still cosecant theta. What's 1 over cosecant theta equal to? It goes back to sine theta. Good. Okay. Any questions on that one? All right. I want you to look at number 17. Similar kind of thing, not exactly the same. I want you to see if you can do 17. Use some reciprocal identities. Okay? Everybody try it. Annalise, you can go. Huh? Yeah. Mm-hmm. Okay, let's take a look at 17. Okay. So the can I do anything with sine? No. So I'm going to leave sine the way it is. Okay. What's another way to write cosecant? 1 over sine theta. Good. I'm just going to leave secant theta there. All right. What happens with these sines? They cancel. Good. So I get 1 over secant theta. Okay. What's 1 over secant theta equal to? Cosine theta. Okay. All right. How do I do 1 times 7 and 18? Perfect. All right. Any questions on 17? All right. Let's take a look at 18. Okay. Right now I'm looking at that and I don't see really any connection to anything yet. Okay. But I do see some algebra in there that looks familiar. Okay, even though it's got cosines and secants in it. That letter, by the way, is the Greek letter beta. Okay, I tried to throw some other Greek letters in there just so you could see them. What's instinct telling you to do right now? Look at the algebra. What's instinct telling you to do? Distribute. So if I don't know what to do, I'm gonna do the algebra. I'm gonna distribute. Okay. So I've got cosine of beta, and it's like a bee with a tail on it. Okay. Secant of beta minus. So when I am multiplying a cosine times a cosine, remember how we put the exponent on the trig. So I'm going to say cosine squared beta. Okay, I'm going to see if I can do something with that. Okay, so I can't do anything with cosine, but I know I can do something with secant. What's another name for secant? 1 over cosine beta. Yep. I'm going to keep this part here at the back. All right, but Edgar told us, hey, we're going to cancel. So what's this first term become? 1. Good. 1 minus the cosine squared beta. Okay. That's triggering something in my brain that says, oh, that kind of looks like that pink Pythagorean sign in Mrs. Ballard's classroom, right? So look over at the pink Pythagorean sign again, okay? All right, it's 1 minus cosine. Do I have a 1 minus cosine up there? Yep, so look at the first row, third column, right? What's it equal to? Sine squared beta. So basically that this function here that we had originally is equivalent to sine squared beta. Okay, it's the same thing. Okay, any questions on that piece? All right, let's take a look at 19 and see what we can do with it. Again, it looks a little bit different, right? A lot of the same elements are probably there, but it looks a little bit different, okay? And I'm not sure that this one is going to get as simple as the rest, okay? All right, so I don't know what to do with sine. I'm going to keep sine. I don't know what to do with cosine, so I'm going to keep cosine. What's another name for cotangent? So cosine over sine. Okay. All right. I'm going to see if I can get this simpler. I'm seeing that I have sine theta plus, and I know cosine times cosine is going to be cosine squared theta over sine theta. All right, this one's going to be get super complex really quick, okay? It'd be handy to make that look nicer if I had the same denominator, wouldn't it? Okay, so this one has a denominator of 1, which would make my common denominator sine theta. Everybody see that? Just as if there was a 2 here and a 1 there, I'd make the common denominator 2, okay? So I'm looking at what I have to multiply by. So if I have 1 and I have to get to sine, what do I need to multiply by? Sine, good. We're doing the same algebra and the same arithmetic we've always done, but now there's trigonometry in it, okay? So if I multiply the bottom by sine, I also have to multiply the top by sine, right? That's the rule to make an equivalent fraction. What's sine times sine? Sine squared theta, good. This second one is already over the common denominator. So do I need to do anything to mess with it? No. Plus cosine squared theta. Okay. Test writers like SATs, PSATs, probably not SBAC, okay? Rarely AP calculus, but every so often. This would be a good, like, you go to college and you're taking calculus. Some calculus professors love to embed a lot of trig. Okay, so this might come up. And they love this particular one. Okay, look up at that sign. Look for sine squared plus cosine squared. It's the very first one, right? What's sine squared plus cosine squared equal to? 1. Test writers love to look for the opportunity to make trig equal to 1. Okay. All right. One of our other rules we talked about earlier, kind of rule of thumb, is we don't like denominators with trig. If we can get rid of it in a denominator, we do. What's 1 over sine equal to? Cosecant theta. You guys, look at that problem. Look what we started with, and look at what we ended up ending with. Okay? So your goal is to try to kind of keep manipulating it till you can get it as simple as you possibly can. Okay? Any questions on 19? All right. I'm going to stop there for today because we've only got a few minutes. But just I want you to look at the first word in the next sentence because I want you to get excited about tomorrow. Look at what we get to do with trig. We get to factor our trig tomorrow. Doesn't that sound like so much fun? I think it sounds amazing. Okay. We get to factor. We haven't done that in a while, right? Okay. You guys, I wasn't ready to give you homework on this. We will do the homework tomorrow. I want you to finish up the other 2 homework assignments. Okay. So make sure you're getting those other 2 homework assignments finished for tomorrow. All right. It takes practice. You guys, you have to practice, okay?